All right, before we get into content, your wonderful TAs have the quizzes and interviews graded. You can check Autolab. Your grades, your results are posted on Autolab. There should be an interview and a quiz section on there. So you'll see, if you click on that, you'll see if you got the learning objective for the quiz and interview, and also the application objective for the quiz. To get feedback, to see your feedback, click on your score, and it should pop up with some comments about how you did. If you got credit, especially for the AO on the quiz or the LO for the interview, your comment's probably like, great job, you did great. If you didn't get all full credit for everything, it'll have some explanation what you did wrong. And especially on the quiz, go to this week's lab, and you can get review. In this week's lab, the TAs are going to review the quiz from last week. So especially if you didn't get credit on the quiz, show up to that lab and see exactly what was expected for that lab. Just a reminder, the application objective on the quiz, you can only earn that on the first attempt. That was only on last week that you can earn that. So if you got the learning objective but not the application objective on the quiz, there's no reason to show up next week for the quiz unless you have to show up to do the interview. Taking the quiz next week, you can't earn an application objective on the quiz next week. So just make sure everybody remembers that, and don't waste your time taking a quiz, 2 hours of your life for something you can't get. You can make it up on the final exam, though. That's the next chance you get to make that up. Yeah?
So it should just be 1 point for each, right?
Yes. Yep.
If you got both with the total.
Yeah, the total would say 2 if you got both. Yeah, the grades are just 0 or 1. It's just a Boolean. 0 if you didn't get credit, 1 if you did get credit. So 1, that's the score you're looking for anything in Autolab in this course. You're looking for a 1. A 1 means complete. A 0 means incomplete. Yeah?
What is PLD on Autolab?
That's not something we have to worry about. The PLD on Autolab, that stands for penalty late days. It's a feature in Autolab, but it's not something we use in this course. So it's not something you have to worry about. Yes? What's up?
We just ignore the PLD then?
Yeah, just ignore the PLD. Does it have a value, a non-zero value for PLD?
I have a 2 and a 1.
For like
Okay, yeah, I'll have to change something to make sure it doesn't show up, just so it's less confusing. But whatever PLD says, you can ignore it. It doesn't mean anything for this class. Yeah.
Will the grades ever appear on Gradescope, or, I mean, not on Gradescope, sorry, on UB Learns?
No. No, grades won't ever show up on UB Learns. Everything will be on Autolab. That's where all your grades will be posted, except for your final letter grade will be on the hub, of course. All right, good questions. Anybody else? Anything else? Yeah. Yes. The question is if you want to see your quizzes, is that possible? The same way you view your code submissions, check out the file on Autolab. All of your quizzes have been scanned and uploaded to Autolab. So if you go to your submissions and click on the download icon or the magnifying glass, the icon to view it, you should be able to see your quizzes. Let me know if you're having trouble or if something went wrong with that process. I'll take a look. So your paper quizzes won't be handed back, but you can view your scans in Autolab, so you can see your quizzes. If you have both the LO and if you have both LOs, if you have both learning objectives for the interview and quiz, you don't need to show up to lab next week. There won't be anything for you to do in lab next week, in fact. You shouldn't show up to lab next week if you have both learning objectives. Whether or not you have the application objective doesn't matter, because next week you won't have a chance to do that anyway. You don't have a chance on the second chance to earn the application objectives, but you will on the final exam. You have a chance to make up that application objective. How many AOs and how many are needed for an A? I will defer you to the syllabus for that question. The syllabus has way more explanation on that than I'm going to take time in lecture to talk about again.
have more.
Can you show up next week if you need help on the project, or is that discouraged? I'll say this discouraged. To show up next week, show up this week if you need help. If you want extra help and you want to review more, by all means, show up this week. This is the review week. But next week, there will be students, your classmates will be taking the quiz, taking the interview. They need an exam environment. If you're there asking the TAs questions and distracting everybody, that would be discouraged. But this week, by all means, if you don't have to attend, feel free to still attend and use it as a review session. The TAs have been going through the quiz solutions much faster than 2 hours this week for lab, the labs that have already happened. So if you have any questions, you want any type of review, go there and ask your questions. Some of them have been finishing in like half an hour or 40 minutes. And then they say, any questions? And then they get a bunch of blank faces, and they're like, I don't know, whatever. And then they just do nothing for the rest of the lab. Come there with your questions and take advantage of that time where you have 3 TAs ready to answer your questions this week. Next week, they're going to be busy with interviews, though. So there's no dedicated review lab like there was last time? This week's lab is a dedicated review lab. I just said that. Oh, you probably posted that before I said it. How to use the recovery opportunity for an interview. It'll happen automatically. So if you didn't get credit for the interview last week, you take it again next week and you again don't get credit for the interview, then you'll need to use a recovery opportunity, and that'll be automatic. It'll probably be me sending you an email that says, hey, just to let you know, you used a recovery opportunity. We're going to schedule an interview. You'll interview with someone. I'll leave that blank right now because it's going to depend on how many students need a recovery opportunity. If it's just a handful, if it's just like 5 students, I might do them. If it's any more than that, then it'll be TAs. But yeah, recovery opportunities are always automatic. You never have to let me know that you're using a recovery opportunity because I'm just going to assume that you're going to use one when the alternative is fail the course. Like, I don't have to reach out to you and say, would you like to use a recovery opportunity or fail? I just assume you're going to want to use it. So it's all automatic. Whenever you need a deadline extension, makeup quiz, or makeup interview, it's just automatic. I'll reach out to you. I'll process everything and talk to you and reach out to you. All right, let's get into some content. So let's talk about override. We talked about this a little bit last time, but I want to talk about 2 special methods that we like to override. So remember this chart? Chart should feel less confusing each time I show it. Hopefully that's the idea. Is that all these methods, or all these classes extend any val. All these classes, which is everything else, much, much more than the 3 listed here, and your class is literally every class that you ever write is going to be over on that side, which extends any ref. Those values are stored in the heap. Objects of that type are stored in the heap, and then references are on the stack. And both of them extend the any class. So any is the root class. We say that absolutely any value, every value in Scala is an object, and absolutely every class that those objects are created from extend any in their type hierarchy. So every single value in Scala is an any. It is of type any because it inherits from the any class. And any has a few methods in it that sometimes we like to use. There are 2 methods that I'll talk about today that are in the any class that have somewhat different behavior, whether it's an any val or an any ref. Those classes override some of this behavior. But toString, .toString, and .equals, which is called from the equal method. So if you do equal, that's calling .equals. So this equals method and a toString method are two things that we can do with absolutely any value that we have in our Scala programs. Absolutely any of them. So for example, if we say print line whatever, print line takes an object of type any, it calls toString on it, and then whatever toString returns, it's going to print that to the screen. Dot equals is going to check, are these two things equal to each other with equal equal. We're familiar with using that, but we haven't used equal equal with our custom objects yet. So what behavior do we inherit from this toString and the equals? So the toString for our objects are going to get the anyRef toString method, which overrides the any toString method, which is going to print this garbage. This is going to be the fully qualified name of the class, which is the package and the class name, and then at some garbage. That garbage, we can think of that as a reference. It's related to the reference. It's some JVM abstraction. But we can think of that as the reference, where this thing is located in memory. Usually not what we're worried about when we're programming. But that's the default print line. Print line, just print out a potion. That's what we're going to get. The equal equal method, by default for an anyRef, is going to check if those two variables store references to the same exact object. So in this example, potion 1, potion 2, even though they're at the same exact location and they have the same exact volume, if I just do equal equal on those potions, I'm going to get false, because the default behavior is, do these two variables refer to the same object? No, they don't. They refer to two different objects on the heap. So their values don't even matter. We just get false, not the same object. Potion 3, this was an assignment by reference. Potion 1 and potion 3 do refer to the same potion. So that one we're going to get true. This is the default behavior. If you just use toString or equal equal on your objects that you wrote, that's the behavior you're going to get. Neither of these behaviors are necessarily something we care about. We don't really want to compare by reference or print out this garbage from the toString method. Usually not what we want. So we can override these methods. Just like we overrode the methods that we had in our abstract class, we can override the methods that we inherited from any and anyRef. So I don't want that toString behavior where it just prints out the fully qualified name of the class and then some garbage. I don't want that. I want something more meaningful. So I'm going to print out the location and the volume and get something more meaningful to us. If I'm printing this to the screen, I'm printing it for a human being to read. I want to print some useful information for us to read. So I'm going to have toString return something that's going to give us something more meaningful. Physics vector, in this example, location is a physics vector. So let's override that toString also to print out the physics vector in a way that we expect vectors to be printed, with XYZ comma separated and in parentheses. Then it's going to print out a way that we like. Just give me one moment. I can hear my fan running. My laptop's melting over here. I knew something was running. It's from a previous lecture. I had to kill that. So we're overriding these toStrings, and then when we print out a health potion, it's this toString that's going to be called, which ends up calling this toString and getting this in a better format for us to read. This will implicitly call toString. It's kind of a special method. When we're concatenating strings, we know that this is supposed to be a string, so it's going to convert that to a string with toString. Since every value has a toString, Scala can know that, hey, this has a toString, let's convert it to a string. We can also override equals. We don't want that default behavior of checking the references. Let's give something a little more meaningful. This syntax, I don't want to I don't want to hit you with this too hard right now. You're not going to have to use this syntax at all this semester, right? We only use this in concurrency, and we're not doing concurrency this semester, which you should be grateful for. It's such a confusing topic for a second semester. So with this syntax, what we're doing is checking the type of the object that we're given. Equals is going to take anything. You can compare any two values using equal equal in Scala. Because equal takes a variable of type any, and everything is of type any because everything extends any at one point or another. Somewhere in its inheritance chain, it always ends at the any class. So this takes an any. Since it's any, we're going to first check the type of the object that we're given. And I'm going to use this syntax to say if object is of type health potion, then compare them by volume. We're going to say if two health potions have the same volume, we're going to consider those equal. Just arbitrary, just whatever. But the point is that we can code anything we want. We get to decide what determines if two health potions are equal. Whatever you want to code, that's what you decide if they're equal. If it's not a health potion, so if it's any type other than health potion, just return false. Comparing a health potion to a dodgeball, they're not equal. Let's just say false. It has to be a health potion to health potion comparison. Now we run the same exact code, just with those overridden methods in the health potion class, and we get very different behavior. When we print health potions, we actually get something meaningful here. We actually get the location and the volume printed to the screen in a format that makes it easy to see what information is being communicated, not just the name of the class and some arbitrary reference. And when we're comparing health potions, even though potion 1 and potion 2 refer to different potions, they're compared by volume. Volume of both are 4, true. Potion 3 and potion 1 refer to the same object still, but we're not even caring about that. We're saying, do you have the same volume? Well, it has the same volume as itself, 4 and 4, true. So very different behavior by overriding these two methods. This can be very helpful in debugging, especially in Project 2 when you're writing your own classes. You'll be at a point where you're writing all your own, a lot of your own classes as you go through the assignment. It can be very helpful to add a two-string method, like maybe a two-string method in the item class, so you can print out items as their description and price instead of getting store.model.items.item at some garbage. You're really not going to use that during your debug process. It's not helpful. But if you override the items to string to print out, to give the description and then the price of that item, or maybe whatever other variables you want to display, now you're getting some useful information. That can help you in your debugging. If you're, you should be writing your unit test, but in your unit test, sometimes it helps to even add a little bit of print line debugging. No matter how much formalization we have in testing, sometimes a good old print line can still be very helpful. Print out those things, get some useful information out of them. Any questions before we go to the next scary big example? Could you override dot equals to automatically account for margin of error for doubles? Yeah, but you probably don't want to. Like you can modify the double class, like extend double and then override it. I believe you could do that. I think it'd be more pain than it's worth. Yeah.
The override for dot equals in potion class.
Yes.
Potions to dodgeballs. Actually, on the next slide, you were comparing like you were only comparing potions on the next slide.
So if I said if potion 1 equal dodgeball, that's going to get caught here. So this is saying if it's of type health potion, this is how you compare them. If the object that we're comparing to is of any other type, this is a wild card, which says any other type that's not health potion, just straight up return false. So if the type is dodgeball, it's just going to return false. It's going to say they're not equal.
Even though, like, what if you put like dodgeball first? Like, how would it know? Like, what if you had a different override for dot equals?
I'm not 100% on this, but I believe it's whatever one is first. Like if I do potion 1 equal dodgeball, then it's going to call that equals. And if I do dodgeball equal potion, it should call the dodgeballs equal. Okay, any other questions before we get into our example? Who's ready for this one? Oh, actually, before, so this abstract class, can we create an object of a type that's an abstract class? Yes, no, maybe? If I have an abstract class, can I create objects of that type?
No.
No. All right. Let's get this out of the way. Not to give it away or anything, but and then the rest of the lecture will be the example in the slides. Anyone need more time? Okay, let's get to it. And I'm hoping everybody can read this. If you're having trouble in the back, this is how small I have to have the font to read it. I think it might be okay. Let me know if it's not. At least for today, we'll have to live through it. But if it is trouble, I do have to do these memory diagrams in slide. I want to do them in slides. But either way, they have to fit on the projector. So if that is becoming an issue, let me know. At least for today, you can download the slides from the website if it is causing issues. I don't see anybody complaining, so I'm going to assume that that's okay, and that as long as this is my minimum font size, I can get away with it. All right. Who's ready for a big old memory diagram? Let's do this thing. Okay, so I have a program here. We have some classes. This is similar to what we saw on Wednesday and similar to what we saw earlier in these slides, but I did change this a little bit just to reduce the tedium of going through this example. For example, I changed it to x and y instead of having a physics vector, because the physics vector would be an extra object on the heap with references going to that physics vector, which I was having trouble fitting on a slide, to be honest. So health potion is going to have an x and y location as two doubles, and then still have the volume. Dodgeball, x, y location, and mass. Game object, x, y location, and then physics vector, x and y. And then I cut out some of the methods, again, so I don't have to do tiny, tiny font. So let's begin. We always start right at the main method. So let's go through this thing and see how inheritance affects our memory diagrams. How do we do this with inheritance? And as we go through this, seeing exactly how inheritance works even. So let's talk about it. There are a few big things that we need to talk about in this one. Okay, so the first step, nothing fancy here, nothing new. We're going to call the dodgeball constructor. This is going to return into a variable named ball. Put that on the stack. Put a stack frame. On the interviews last week, we had a lot of confusion about some of the terminology. We're putting a stack frame, which is created every time a method is called. We're putting a stack frame on the stack. So the stack is the entire thing. When a method is called, we add a stack frame, which is the solid box, to the stack. That stack frame is going to get the parameters plus our hidden parameter of this, which is going to refer to the object that's being created. So we have this dodgeball being created at memory address 350. This is going to store the reference 350. And then we're going to take all the constructor parameters and add them as state variables to the object that's being constructed. Oh, stop doing it. To the object that's being constructed. All that at this point should be very familiar. Calling a constructor, we've done this, I shouldn't say very familiar, but pretty familiar. We've been doing that for a week and a half now. We should feel pretty good about constructor calls, adding stack frames, creating objects, passing by reference, things like this should be starting to be second nature now. No, I don't want to. The new thing here that we haven't seen yet is when the dodgeball constructor is called, it's also going to call the game object constructor. The game object constructor is another method call. So we're putting another frame on the stack, another stack frame on the stack with its own set of parameters and a reference to the object that's being created. It's the same object that's being created, but we're going into a second constructor call for the superclass. We're calling the superclass's constructor, and we do get more state variables. These variables are inherited. The dodgeball class inherits these variables, which means those variables are state variables in the dodgeball class. So in addition to xdb and ydb, we also have x object and y object as state variables in this object. The game object constructor then calls the physics object constructor, and we hit our third level of inheritance. We're going down to the physics object constructor, which takes two parameters, x and y, the implicit parameter of this, which refers to the object that's being created, the same object, and those constructor parameters also become state variables. So we get state variables from all three constructors here. And then technically, this goes deeper. We don't have any explicit inheritance from physics object. So physics object implicitly extends any ref. We would call that constructor. The any ref constructor is going to call the any constructor, and then we have our object fully created. We're not going to show all the internal steps. Anything internal to Scala, like the stack frame that's created when println is called, we're not going to worry about that. The stack frame that's created when a new array is created, we're not going to worry about those. We're only going to worry about our code in our memory diagrams. But technically, there would be two more constructor calls here. So we have our three. We have all of our state variables. And we get those parameters, those state variables, from all three constructors. After the constructor is called, after we get all the way down to the bottom of our inheritance, then any code that's outside of the methods, now we don't actually do this in this example, but this is where any code outside of the methods in the physics object class would be called, and then that constructor would return. We go back to the physics object, or the game object constructor, run any code that's outside of the methods in this class, return, run any code that's outside of the methods in dodgeball. Again, there's no code in this example, but if we had extra code there, extra state variables being created, they would be created on the way up as these stack frames are returning. Because we have, think of this as lines of code. we have a method call. The first thing this method does is call another method. After that method returns, then we run all the rest of the code. So the order can be important there. Usually we just code in ways where the order isn't important, where it's going to have the same effect either way. But this would be the order in which everything's executed. Dodgeball is going to return. And we finally get our reference to the object that was created in this variable named ball. So we're going through all three constructor calls when we create an object of type dodgeball or an object of type health potion. Going through all three constructor calls one at a time, starting with dodgeball. Dodgeball extends game object extends physics object. Go through all the constructor calls and get all of the variables from all of the constructors and any variables declared outside of the methods. They're all going to become state variables of this class, or of this object. So you think about it for a while. How is this going to work for our health potion? When our health potion constructor is called, it's going to be very similar. But I'll give you a few minutes to think about that, so you can see how well we got that. It's this question. Can object X be named the same as XDB? Yes. So my typical answer for this, could we name all of these just X? The answer is yes, but I'm not going to in lecture, and I recommend that you don't in your assignments. The rules get wonky, to say the least. So these are all separate variables. If they are the same name, like if we name those all X and just Y, we'll have 3 variables named X and 3 variables named Y in this object. So when you say X or Y, which variable do you get? Which value do you get? The answer is it's complicated. We got to dive into a whole new wealth of scoping rules. The answer is going to be 1, if we can't straight up do it because I have these all declared as var, and 1 val. But these are all vars, which means I would get an error. If I reused a variable name, I'm going to get an error that says you already used this name, because val or var means you can access this variable from outside of the class. So if I have 2 vars named X, and outside of the class I say potion1.x, which X do I get? We have a name conflict. They're both in scope. We don't know which one to use, so you're just going to get a compiler error. Nothing's going to work. So only one of them can be either val or var, and the rest have to have no val or var on them. And then when you're within a class, if you're inside dodgeball and you say X, you'll get the X from the dodgeball constructor. If you're in game object and you say X, you get the X from the game object constructor. If you're in physics object and you say X, you get the X from the physics object constructor, which is just asking for bugs. You change one of those, you think you're changing a different one. It's messy. Easiest answer is to just not reuse variable names and not have to go into that whole conversation. Because goodness, putting that on a quiz and saying, make sure you use the right X, oh my goodness. That's just asking for trouble. That's setting you up for failure, and I don't want to do that. Does changing XDB change object X? No. If I change this variable does not change. If I change this one doesn't change, this one doesn't change. They're 3 separate variables. If these were physics vectors like we had before, since physics vectors are references, they would all refer to the same object, and then you would still see all of them update. They would behave that way. Since these are doubles, they will change independently if we change them. And if not, when you call the parent class methods, how does it know which state? Because we'll use the appropriate, so these all have different variable names. We'll just use the right variable name for the one that we want. Yeah, it knows which state variable to use because they all have different names. So that's why we're going to name them differently. If they didn't have different names, it would be whatever one was declared with val or var. I was hoping to completely avoid this conversation, but it's, I guess it's inevitable. The child would be dodgeball and the parent would be game object, yes. I'll add to the yeses. So we always draw stack frames separate from each other. So these are 3 separate stack frames that are completely independent of each other. Each stack frame happened to be created while code was executing inside one of the other stack frames. That's fine. But in the machine, each stack frame is its whole other environment. So we never draw stack frames as nested. I tried to get 1 pixel gaps between these things. That's how much I'm utilizing my space here. But these are separated. There should be a gap between these stack frames. They are completely separate environments of execution, completely independent of each other. The only thing that's similar is that they happen to return execution back to the other stack frames when they're done. Yeah, the short answer to if these are all named X and Y, the shorter answer is, well, Paul and I talked about that for like an hour and couldn't come up with a concise thing to say, so we're like, we're just going to avoid that one. It gets into some strange behavior of Scala that we just don't, it just detracts from what we're actually talking about the concept of inheritance. All right, everyone got this? You had enough time to stare at the health potion? So it's going to call the 3 constructors, similar to dodgeball, health potion. The difference is volume instead of mass. That calls the game object constructor. That calls the physics object constructor. And we get all of the state variables from all 3 constructors. So very similar to the dodgeball class, which isn't surprising since both of them extend game object. So everything from game object down is going to be the same. All that's going to be the same. Different values, of course. But all that's the same. The only difference is the dodgeball constructor. These are named differently. And we have mass. These are named differently. And we have volume. So a health potion won't have an XY DB. A dodgeball won't have an XY potion. But they both have XY object. And XY, just straight up XY from the physics object. Yeah?
What's the difference between an abstract class
Between an abstract class and a regular class?
Yeah.
So an abstract class, we can't create instances of it, is one of the big things that we just had in the lecture question. But an abstract class, if we have an abstract method, so this is an abstract method, meaning it doesn't have a definition. I don't have equals and then braces and then any code or anything. I just have the header. What's the name? What are the parameter types and what's the return type? That's all I have here. This is what we call an abstract method. And if you have even one abstract method, your class has to be abstract. Because we can't, if we have any abstract methods, we can't create an object of that type because it's not fully defined what this is supposed to do. What happens if we call object mass on a game object? I don't know. It's undefined. So it has to be an abstract class. It's just an abstract concept. It's not something we can hold. We can't just hold a game object. We can hold a dodgeball or a health potion because they're fully defined. You can also use, I'll expand on that a little bit. So physics object is actually fully defined. There's no abstract methods here. I'm still labeling it as abstract just to prevent objects of type physics object from existing. I don't want anyone to say new physics object. It's behaving as an abstract class because I'm never going to say new physics object. So I'm labeling it as abstract to prevent new physics object. And because we're talking about abstract classes, so I want to label it as abstract. If I deleted abstract right here, everything in this example would work exactly the same. If I delete abstract right here, I get an error because it has an abstract method. Yeah, you need to draw the arrows. All these arrows should be there. If that was your only thing on the quiz, I don't think we took away an application objective. I think you still earned that. But we gave you a little note that said, don't forget your arrows next time. Okay, let's do another exercise. That was so fun, let's do it again. So potion 2 equals potion 1. How's this going to work? Yeah.
You said that object mass was an abstract method. How do we use abstract? Just nothing in it.
We don't directly. So each of dodgeball and health potion have to implement the abstract method. So in both of those classes that are not abstract, that extend game object, have to have definitions for object mass. So that's why both of them define and override that method to say, here's the definition. Now that I've satisfied that method and made it no longer abstract, now we can create health potions and dodgeballs.
So it's kind of like declaring that kind of like a variable declaring other classes.
Yes. Yeah. So the game object class is saying anyone who extends me will have an object mass method that returns a double. Guaranteed. They have to. They have to, or else they're going to get a compiler error. They have to. And then we're going to leverage that information. Starting on Friday, we're going to leverage that information to say every object of type game object has to have that method. I don't know what it's going to do, but they have to have that method. It has to exist. And we'll see that we can have data structures that actually mix health potions and dodgeballs in the same data structure. And we can call object mass on them, knowing that that method will exist. Even though we won't know if it just returns this dot mass or if it computes mass based on volume. All right, everyone good on this exercise? How many constructors are called when potion 2 is added to the stack? Hundreds? None? I heard none. None. This is strictly assigning a reference. That's it. So potion 2 equals potion 1. Potion 1 stores a reference. Potion 2 just gets that reference. That's it. No constructors. We're not going down that. We are not creating a new potion. We're just assigning by reference. That reference stored in potion 1, potion 2 gets that same reference. That's it. Nothing else happens. There's not a new object created. There's no constructor calls. Nothing's being copied. We're strictly just giving that reference to that variable. Potion 1 and potion 2 refer to the same object in the heap. Hopefully we've seen that enough times that that's good with everybody. Because I guarantee that will be on your quiz in 2 weeks. Guaranteed. You have to understand how pass by reference works. Okay, and then if we say ball.x plus equals 1, we're going to update that x. Well, let me go through the whole thing. Ball stores reference 350. Go to the object at 350. Go to its x variable and update that. So these variables update independently. I only changed x. That has no effect on x object. It has no effect on x dodgeball. It just updates x and x only. So we have to be careful if we're accessing these variables. What I will do is be consistent and always use just x and y and treat those other variables, those other state variables, basically as if they don't exist. Like, I don't really want these variables or these variables to even exist, if I'm being honest about it. But I need those variables because they need to be used for transitory purposes. I take these variables just to forward them to the next constructor. I take those variables just to forward them to the next constructor. And then it's these variables that I actually care about, the x, y, in the physics object. Those are the ones that I'm going to end up using. It's semi-arbitrary, but starting Friday, we'll see why I chose the physics objects, x and y, and not any of the other ones. The short answer is because our physics engine will use those x and y, because that's the only ones they'll have access to. So we'll use those x and y, and they update independently of the other ones. So I'm going to be careful to never use these, because these store old information I don't need. I'm already done with my reason for having those variables at all. It's kind of just a side effect of Scala taking every constructor parameter and turning them into state variables. Sometimes we don't want that behavior, but it is the behavior that Scala has. Holy crap, we only got 2 minutes. All right, so if we don't finish, we'll continue this one on Friday. We gotta talk about the inheritance stuff. We didn't even get to the good stuff. Ball.object mass. Here's where we get our first big inheritance question. So ball.object mass, we have object mass and object mass, but which one is going to be called? Well, we look at the object that's calling the method, and we see that that object is of type dodgeball. So we're going to check the type of the object that's calling the method. This is of type dodgeball, so we're going to look for the dodgeball class and call dodgeball's object mass. And that's the one we're going to use. This.mass, this.mass, print 2.0 to the screen. Potion2.objectMass, potion2 refers to a health potion. So we're going to go to the health potion class and call this object mass. Put mass per volume on the stack. Compute the multiplication, print 42 to the screen. Ball.toString. Ball.toString. It's a dodgeball, but now we have an issue. Now we have an issue. We don't have any toString method in the dodgeball class. So what we're going to do is look in its superclass for a definition of toString and keep going up the inheritance chain to find that method. We find it in GameObject, so this is the toString that's used. And then when we print out potion, we do find a toString, so that's the toString that's used. And we print those things to the screen. I'm out of time, but I'll explain that last part in more depth on Friday. See you then.